this first part, so in this session we talk about things, new services and tools that are available to experimenters. We also like to hear from experimenters on their experiences, and people in the room who are involved in building Genie tools can hear from you experimenters and maybe improve on your Genie experience. So I'm going to be talking about a piece of software called Genie in a Box. And Genie in a Box is intended to be a quick way of getting started with Genie. It's not really getting started with Genie, learning about Genie without actually having to apply for an account. The reason we have you apply for an account is because you're getting access to real resources, and if bad things happen, we need to know who to go talk to. With Genie in a Box, all the resources you use live on your laptop. So Genie in a Box is essentially a VirtualBox virtual machine that you download onto your laptop or your computer. And it includes an experimenter tool, Omni. It includes a slice authority. It includes an aggregate manager and resources. So it's essentially a small Genie with one aggregate with limited numbers of resources available to you. This Genie in a Box aggregate manager talks to Genie AM API. It understands Genie standard RSpecs. Its interactions with the Omni tool are no different from how any other aggregate would interact with the Omni tool. So you get the complete experience of setting up experiments, running experiments, connecting to the resources that were given to you by the aggregate manager, and installing software and so on. I just remembered I have like the printout of some of the essentially the web pages, the stuff I'll be going over. So if you can follow along if you want, take notes. So, if you want a copy of Genie in a Box, just talk to me. I have a bunch of USB drives with the VirtualBox VM image on it, and I'm happy to share that with you. So, how do you use Genie in a Box? So the first thing you do is, of course, you have to have VirtualBox running on your computer, and you download the Genie in a Box virtual machine image. It's about 1.7 gigs, so it's a fairly large download, but not overly so. So I'm going to walk through a demo. I'm going to actually run through an experiment in Genie in a Box where we will get resources and run an experiment. So this is what VirtualBox looks like. In this case, I've already imported the Genie in the Box virtual machine. So I start it up. So this is going to load up, in this case, Fedora 15 in a virtual machine. There are two flavors of Genie in a Box. There's a Ubuntu flavor and a Fedora flavor. So if you pick the Fedora flavor, then all the virtual machines you get are also Fedora, will have Fedora running on them. And the other flavor gives you Ubuntu. So it's starting up. We should get there, the Fedora desktop. And I'm going to start up a terminal. I'm going to make sure you can see the entire screen. All right. I just want to make sure you can see the, let's see. I'm trying to fit it to the screen here so it's not cropped up there. Let's see. There. All right. about that. There. Right, that should be good for now. So I have a command prompt. So I can now use the Omni tool to ask about the aggregates that are available to me. So as I said, the tool already, the Genie in the box comes with its own slice authority. So I ask Omni to list all the aggregates available to me. So this is Omni now talks to the built-in slice authority and comes back saying, I have one aggregate available to me, and that is at this URL, http genieinthebox.net 8001. I can now go to the aggregate and ask what resources it has for me. So use Omni again, list resources. I'm going to talk to this aggregate, which is this long URL, but I have a nickname, GIB, so you don't have to type the long nickname. The long URL, list resources. I came back with a list of resources. This is essentially the advertisement RSpec from this aggregate. And let's look at one node. So it's got in one of the nodes, example of one of the nodes from this aggregate. It's an OpenVZ container. It's a virtual PC running Fedora 15. It's got network interfaces on it. It's got ETH0, which is for control, ETH1, ETH2, and ETH3, which are for experimental use. So essentially, if you look through the entire RSpec, you'll find 6 such nodes, each node implemented as a Linux container. Each node has 4 network interfaces on it, very similar to what you'd find in Proto-Genie. 3 network interfaces available for experimental use, 1 for control. So now that we know what resources we have, we can write a request RSpec, ask for resources. If you go to the Genie in a box directory here, I have some number of RSpecs that I've pre-created that you can use. Of course, you can create your own. For this demo, I'm going to use this RSpec called 2nodes iperf.rspec. While it's actually creating the sliver, I'll describe to you what this RSpec is, what this experiment is doing, because creating a sliver takes a while. So I'm going to the first thing we do is create a slice. So omni.py create slice. Demo slice. So it's going to go to the slice authority, create a slice. Now I can actually create a sliver. Omni.py create sliver from the GIB aggregate. Sliver, thank you. Let's see, I get the aggregate's name. Now I need to give it the slice name, which is demo slice, and the name of the RSpec. All right, so it's gone off trying to create the sliver. So what experiment are we running? The experiment we're running looks something like this. We're going to get 2 nodes. We're going to call one left. We're going to call the other right. Use one interface on node left, one on node right, connect them up with a simple local area network. We then install iperf on both these nodes and run iperf as a server on node left, as a client on node right, and see what kind of bandwidth we get. So really simple experiment. If you want to see the RSpec, we can, it looks like this. Well, I can go to the VM, create a new terminal. Oops. I'll just create a new terminal window so we can there. I'm going to create a new terminal window so we can look at the RSpec there. So as you can, this is the RSpec. You can see I'm asking for, let's go to the top, asking for a node. running. You can ask for whatever OS you want. You're going to get Fedora 15. You can ask for whatever type. You can ask for a raw PC or a VM. You're going to get a VM. So, and so in this RSpec, I'm asking for a node. I'm asking that when the node comes up, this shell script that I have at this location get downloaded and installed. And I'm asking that once the node's up, that shell script be automatically executed. And so that happens on both nodes, left and right. And I'm asking for a link between the two called left-right LAN that connects the two interfaces. So it's your standard RSpec, no different from what you would use for any other Genie resource. Okay. Let's see what's going on. Do we have our slice yet? Okay, it's still in the process of creating a slice. So while it's doing that, let's go see what the shell script looks like. Probably easier to see it here. This is essentially the shell script that's going to be downloaded and installed. All it does is it checks the host name. Is it? I don't know if it's readable. Am I host? If my install iperf on both nodes. If my host name is left, I'm going to start off iperf as a server. If my host name is right, I'm going to start iperf as a client. So really simple shell script that's going to get downloaded and installed. Now, okay, it's still working. The create sliver takes a little while because it's creating the file system for both the VMs, downloading the software, installing it. So that takes a few many minutes, but it should be we should be getting there soon. So what we're going to do is once create sliver is done, we will actually go look at the output that we got from the iperf server or client. If you notice the RSpec, I had or the shell script, I had the output of iperf go into the special directory, www.html. I put it there so then we can use a web browser to see the output of iperf or server or client. We can also SSH into the nodes and look at this file. When you SSH into this nodes, you also have root access, which means you can sudo and you can run commands as root. It's going the wrong way. Always seems to take longer when a lot of people are watching.
Should we look away?
Yeah, go get some coffee. So if you're curious about implementation, all these virtual machines are implemented as Linux containers. So they are lightweight in this, you're probably not going to believe the lightweight part since it's taking so long to create, but they really are lightweight in terms of resources consumed on your PC. And the Genie Aggregate Manager actually parses the RSpec, creates a number of virtual machines you need. And in order to connect these virtual machines in the experimenter specified topology, I use Linux bridges. So Linux bridges, there's a bridge per link in the in the implementation. I'm just going to peek to see what's going on. So the aggregate manager writes to a log file, so I can keep track of what's going on. Yep. Yep.
So could the aggregate manager be made to look like one of the real aggregate managers?
It supports the Genie AM API just like a real aggregate manager. So it is a real aggregate manager.
I mean,
but
in terms of the resources itself.
Well, it's an aggregate manager whose resources are VMs. So it's
Right. That's fine, but essentially, given our spec in terms of, or put a query to discover the resources,
yep.
it would be nice if it returns the same thing as, say, Emulab, but then underneath it maps it to VM.
The RSpec it returns is the same RSpec standard that Emulab returns. It's the only difference is this has virtual machines as opposed to physical machines. So the details of the RSpec will be different, but it's the same standard RSpec. And if we had FLAC, which we don't have right now, but it would be able to show you the same, parse it and show it to you just like it would for any other
I guess my
diagram.
question is, if a student wants to eventually run experiments using the U-time,
Yep.
right?
Okay.
But then use this as a starting
Yep.
point,
Yep.
get all your scripts right,
Yes.
everything else right.
So actually, if you look at the wiki page for this, there's a section on how to move your experiment from Genie in a lab to Protogenie. Yep.
But this is, Karan, you're getting exactly, I think, the question we're trying to think about, which is, what are the right use cases for this capability, and how far do we want to push it? You could imagine trying to, and I don't think this is a good path to pursue, you could imagine trying to replicate all of the capabilities of Genie or selected Genie aggregates down to bug compatibility, right? Inside Genie in the box, and that's clearly sort of an endless and fruitless endeavor. On the other hand, you want to get close enough that the people who need this particular bit of scaffolding in order to get started will actually find it beneficial rather than distracting.
Yeah.
So
No, I think
looking for advice on where to draw that line. This is very helpful.
Yeah. No, I think this is a great start already. The next might be that the aspect returned by the local Genie in a box looks, in terms of resources, exactly the same as, but underlying it somehow back to virtual display.
Right.
So I missed if you said this. So the virtual machines that are being created as part of the experiment here are what? They are
The Linux containers.
They're Linux
containers. Open, just like InstaGenie, the OpenVZ containers.
Because so one of the things that we have been doing recently is making it easier for people to import images that they made someplace else. So if it is possible to let people make their VMs here, or make their containers here, get, put all the crap in the file system that they want, right? And then hand it off later to a quote-unquote real aggregate to run that same image that they built here. That would seem to be very useful. Because one of the things we've been trying to figure out is, if we have some software and stuff that makes the container work better or more integrated, how do we get people to install that if they're making their own images? But if they're starting with Genie in a box and all that stuff is already in the image that they are using, then it would be a very nice, straightforward migration. Yeah. So I think this is a really good point.
And it's no accident that the nodes here, the resources here, have 3 NIC cards for experimental use. It's a lot of it is modeled after the Protogenie Emulab setup. There are instructions on how you can move your experiments from, or some tips on moving your experiments from Genie in a box to Protogenie. Things that are slight differences, the similarities, things you have to change in your aspects. So, for example, the URN for the Aggregate Manager. You want to say Emulab or Protogenie as opposed to Genie in a box. Though you can take your Protogenie, Genie in a box doesn't care about the component manager name. So if you call this Protogenie, it'll still parse it and give you resources. So it looks like our create sliver is completed. We got resources. If we look at one of these nodes from which we got resources, we'll see that, let's see. So we got a node called write. It's got it's running Fedora 15. You have a login now, and here's the fully qualified name for the host, PC102 genieinthebox.net. The interface has a MAC address and a IP address. So you have all the information you now have to use this node. In our case, first, let's just start. Instead of using Firefox, since you're running out of time, I'll just SSH into the node, and we can look at the files we created. So I'm going to SSH into the first node, -i /gib user PC101. So this is the node we call left. Oops. Oh, sorry. If we could not find the file. .ssh, sorry. All right, so now we are in node left. So we can go to the directory where we stored our iperf output. HTML cat iperf. This is the server log that was generated by iperf server. What I'm going to do now is, and if you do an ifconfig here, for example, you can actually see the interfaces that were created for you. There was ETH1, which is your experiment interface that has the IP address and a MAC address, and this is your control interface, and so on. What I'd like to do now is log in also to the other node right, run a ping between the two, and then if we have time, maybe do show that you can use TCP dump to actually see traffic go between the two. All right. So I'm going to create a terminal here. All right, tab. I'm going to SSH into the other node now. SSH user PC102. So this is the node that is called client. I'm going to start ping of the node called left. So it's pinging node left. I'm going to go back to left now and run TCP dump, and you can see the packets coming. You should see the packets coming in. All right, so I'm in node left, as you can see from the command prompt. I'm going to run TCP dump on interface ETH1. Oh, I don't need to be root to do that. And you can see the ping packets coming in from node left. So it's essentially you're getting a VM. You can debug your experiments using standard Linux tools. You can install your software. In this case, we installed iperf. So it is a resource you have complete control over. And as I said earlier, you can get up to 6 of these VMs and connect them in arbitrary topology, so long as the topology does not require more than 6 nodes and no more than 3 NIC cards per node. So that's essentially it. Now we can, I can exit out of this. I'm going to log out of node left, and I'm going to delete my resources. So need.py delete sliver, demo slice. And should clean up soon. Any questions while it's cleaning up?
So what are you using as what are you using to actually spin up the containers and stuff? Are you using like Vert or
OpenVZ tools, so VZ create, VZ, yep.
You're using this.
So it's standard VZ, yeah. And as I said, if you're interested in trying this out, I have the virtual machine image on USB drives. You're welcome to take some with you, and or you can contact me after anytime, and I can point you to where you can download this from. Okay.
So it sounds like you're in sort of public beta at the moment.
Yeah.
I mean, like, when do you think I hope you at some point hope to be able to like link this thing off of the front page.
You can get to
Off of some kind of getting started with Genie thing, right?
Yes, yes, that's the plan. You can find it now through the Genie wiki. The software is not in the wiki only because it's more to do with the size of the files our web server can don't provide right now, serve right now. So. All right.
We're eager for comments on this capability that I said. We're trying to figure out what the right direction is to drive it, and what people picture using a Genie in their laptop for.
So this is just my bent because I'm going to teach a class in spring.
Yep.
Using Genie, this sounds like a great thing to use in a class. Do you think that
it's a good way to get started,
Yeah.
but if you're looking for accurate network measurements, say latencies across large distances, obviously this is not the right thing.
Yeah, but I'm thinking, through the semester, have several small assignments.
Yep.
And this looks like a good way to get started. Number one, this is what you do.
Yes, yes, and it's yes, that's the intent.
Okay,
Yep.
great.
Yep.
So
Oh, okay. Yeah.
So one of the things that might be possible is, so this is one way to get started, and then once you get familiar with this, you go get a real Genie account, load your credentials in this VM, and continue to use the same environment, except now you can connect to the real Genie resources. And so that might be one possible direction if you think it might be useful. So, all right.
yeah, I mean, I would like to but yeah, I mean, I kind of like the idea of thinking about this as a way to build an image on your own machine too, that you're gonna then actually go to that maybe at some point you actually deploy
Yep.
out on other Genie resources. So I think just exploring that angle would probably be a cool thing to do.
Thank you. All right. Thank you. Thank you.
Okay.